Hiya and welcome to day 12 of the 24-day extravaganza. It's halfway through. And today I'm going to be dealing with a question that's actually from a practical paper, and it's all to do with, have very little to do with physics and more about how you can read equipment and deal with uncertainties. So it's got a pencil that's unsharpened at both ends. It has a cylindrical graphite core and an octagonal outside body. The student uses a micrometer to measure the width at several points along the length of the pencil. Explain why this procedure is used to determine the value of W. It's worth 1 mark. So the reason this is a practical question, so it's looking at why would you take repeat measurements? And of course, the reason you would take repeat measurements is to eliminate any inconsistency along the pencil to get an accurate average. Okay, so you take multiple readings, of course, to get an accurate average. If you just take one value, you have got an uncertainty in just that measurement. But if you take multiple values, you take away the actual measuring uncertainty, and it becomes more of an uncertainty of the material there. Okay, the students' values are these. They take their width at different points, determine the percentage uncertainty. So the percentage uncertainty is always the absolute over the average times by 100. This is group data. Okay, so for group data, the absolute equals half the range. Okay, so it's half the range. Okay, so first of all, I'm going to work out my average here. So I'm going to look at all these results here, and as you can see, looking at all of my results here, I'm going to add them all up. So I've got 7.23 plus 7.1 plus 7.06 plus 7.2 plus 7.16. And I'm going to divide that by 5, and I get an answer of 7.17 millimeters there. Okay, so I've got my average. My range is going to be the biggest, take away the smallest. So I've got 7.23 minus 7.06 is 0.1. So I divide that by 2, and I get 0.085. Okay, so that's my absolute value. That is my average. So 0.085 divided by 7.17 times by 100, I get 1.2% uncertain. So this is group data. Okay, so this is how you find the percentage uncertainty of anything. Okay, is your absolute value divided by your average times by 100. And your group data, so your absolute depends on what type of data you've got. You've got group data. So your group data is half the range. Okay, so I took the range, which was between this and this one, and then I divided it by 2. I took that, so that's my absolute uncertainty. So this is a plus or minus. And then I divide it by my average and times it by 100. Okay. Okay. So the cross-sectional area at the end of the pencil is given by 0.83 W squared. The volume of the cylindrical core is known to be 9% of the volume of the unsharpened pencil. What is the diameter of A? So if it's 9% of the volume, if the pencil wood and the graphite have the same length, it also means it must be 9% of the area. Okay, so first of all, let's work out the 0.83 W squared. Let's work out the area of the wood. Okay, so we're looking at the cross-sectional area of the wood there. Is this formula here. So I've got 0.083, no, not just 0.83. 0.83 times by W, which was 7.17 squared. Okay, so 0.83 times 7.17 squared is 42.66. 9% of that is, so 9% of that is 3.84. Okay. So I know that's going to be the cylindrical core. So that's going to be pi r squared. So divide that by pi and square root that. I get a radius of 1.1 millimeters. So my diameter is 2.2 millimeters there. Okay. So they're giving you a weird formula. So always have a look with these, have a look at the letters. And then look at what you know about the situation. So this is one of those practical questions where they're getting you to think about just measurements and how you're using it. So very little, there's actually literally no physics involved with this. This is just your understanding of shape and space and maths and how practicals work. A student investigates a rate at which a similar pencil wears through during use. The student measures the pencil along a Vernier scale. Figure 2 shows it in the 0 position. Figure 3 shows the pencil, which is now sharpened, is placed. Read and record the pencil as shown in figure 3. So these are my figures here. I'm just going to zoom in a bit more so you can see them here. So this one is, of course, where it's a 0. And the really useful thing to know is that when it's 0, there is no 0 error there. Okay. So this is the question. It's asking you to work out the value of the pencil, both pencils. How you read a Vernier scale is that this line indicates where it is. So I've got 8 centimeters, 8.5, and this line is between 8.5 and 8.6. So I know my value is going to be between 8.5 and 8.6 millimeters. Okay. So that's what this line represents. Now, what you need to do is you need to look at all the other lines and find when those lines first match up. So I would say here, or here, let's have a look, 8 point, yeah, I would say there. So looking at this position here, you can see they have lined up at 8.5, and it's at the second one there. So there we go. That's what it's saying here, 8.52 centimeters. So the length of this object, if I just zoom out again, here is 8.52 millimeters. Always asking for it in millimeters. I put it in centimeters. So it's asked for it in millimeters, but I've put it in centimeters. So it'll be 85.2 millimeters. Okay. So always be careful with units for this. This is the way they trick you. The pencil's removed and now does 20 lines of a sheet. Each line is 25 centimeters. What is the new length of the pencil? So I'm going to zoom in on this. I'm going to let you have a go. So you can pause the video and have a go. So I've got this one here. So zoom in. Oopsie. Okay. So you guys can have a bit of a go at this if you wish. So what is the new length of that pencil? Pause the video, have a look at this and have a guess. Okay, welcome back. So let's have a look here. It's between 8.4 and 8.4 to 8.4 centimeters. And now looking at this line, trying to find the line that is first of all straight, which is probably, yeah, there it is. It's the 9th one. So the answer, of course, is going to be 8.39 centimeters. So if I zoom out, all the way up here, which is 83.9 millimeters. Okay, so this question, L½ is the length at which the line could be drawn. So what's that? The pencil has done 25 centimeter lines. So it's done 25 centimeter lines. And what it's asking here is how long, if I drew one line continuously, when would that half the length of the pencil? So I started at 8.59 centimeters, and I want to know how long a line I would have to draw to go to 8.59 divided by 2 is 4.295. How long a line would I have to do that? So to go, if I did 20 times by 0.25, so that is 5 meters. When I've drawn a 5 meter line, I have gone from 8.59 centimeters to 8.3. Oops. Oh, I've got my 5s and my 2s the wrong way around here. So I'm just going to change a few of these. Sorry, this should be 3.9. Okay, so this should be 5.2. So I'm just going to change that up to, so 8.52 divided by 2 is 4.26. So I'm going to just change this around correctly, 4.26, sorry. Of course, it's gone from 8.52 to 8.39. 8.52 minus 8.39. I have changed by 0.13 centimeters. Okay, so when I have done a line that is 5 meters long, I have changed by 0.13 centimeters. Okay, and I want to find when I would lose, so I would have had to go halfway through, I would have to lose, so how much to lose 4.26 centimeters. So to find out how many times I need to go 4.26 divided by 0.13. So I've got to do 32.77 lots of 5 meters, which is 163.8 meters. So if I did a line that was 163.8 meters in length, I would get a value there. Okay, I would get lose half my pencil. This doesn't include sharpening. Okay, so this is all about, like I said, this is all about looking at a Vernier scale. This has nothing to do with physics in essence. It's all about your ability to understand how to read equipment, how to find uncertainties, and how to read data. Okay. So that is question 12. So it's day 12 of the 12 Vernier Examiner. A little bit different. Interesting question to think about. Okay. And hopefully that helps.